You're sitting at home and you're wondering what kind of antics Strong Bad is getting into today. So you run over to homestarrunner.com and boom, page can't be displayed. You start to instantly panic and you look down at your shirt and know maybe it can help. But the problem is much simpler. It's DNS. Fun fact, it's always DNS. Today I'm going to walk you through the fundamentals of how DNS works to make these issues less stressful. When you type in a website address, like mikelossman.me, you probably don't think about what happens behind the scenes. We just expect the page to load, right? But there's a silent hero making this all happen, domain name system, aka DNS. Think of it like putting an address into your GPS. Instead of memorizing complex latitude and longitude coordinates, you just search for Starbucks or a street address. DNS does the same thing for the internet, translating those easy to remember website names into the cryptic IP addresses that servers understand. It's often the first thing we blame when something goes wrong with the internet, but we rarely thank it when it's working perfectly. Without it, imagine trying to visit a website by typing something that looks like this. Yikes. Today, we're going to pull back the curtain and take a high-level look at how DNS actually works. We're going to trace the steps involved to get to my website, mikelossman.me. While DNS can handle different types of requests, like finding email servers or text strings used for verification, we're going to focus on the most common one, the A record. This is the record responsible for converting that friendly domain name into an IP address. So let's jump into a whiteboard and draw this out. All right, you're sitting at your computer and you want to go to mikelossman.me. What happens? The first thing that's going to happen is on your computer, there's this file called the hosts file. This is generally where you would statically map domain names to IP addresses. And if there's an entry for mikelossman.me in your host file, your computer won't even bother trying to contact the DNS server. It'll just go straight to that IP address. Now, the next two can be combined into one. This is going to depend on how your systems are set up, but essentially the local DNS server and the DNS recursive resolver really do the same thing. The local DNS server will reach out to the recursive resolver, and that's where we're going to pick up from. So we are going to, from this workstation, we're going to send a DNS query or a DNS request to our recursive resolver. This is typically your internet service provider's DNS server, or maybe you have one manually set, like Google's Quad 8s or Cloudflare's Quad 1s. This recursive resolver will check its local cache. And if there's an IP address inside of that cache, it's going to respond back to your host with what the IP address is of the resource you're trying to hit. Now, before we move on to the next step, it's important to talk about that cache I just mentioned. All DNS records come with something called a time to live, or a TTL. This value determines how long a DNS server stores that record in its cache. Once that TTL expires, the record is deleted, and the server will have to look it up again. This ensures you're always getting the most up-to-date address information about the resource you're trying to access. Now, if the recursive resolver doesn't have the information in its cache, what it's going to do is it's going to send a DNS request to what's called the root name server. There are 13 logical root name servers overseen worldwide by various organizations. And all this root name server is going to do is, in its DNS response, it's going to tell the recursive resolver what TLD server to go to. Now, a TLD, or top-level domain, is what comes after every host name. So think .com, .net, or in my case, .me. So the recursive resolver is going to send a DNS request to the TLD server, And what the TLD server is going to do is it's going to respond with the IP address of the authoritative name server for that specific domain. And then finally, the recursive resolver is going to send that DNS query of what's the IP address of mikelossman.me to the authoritative name server. This server holds all the definitive records for my website. The authoritative name server is going to respond back with two things. It's going to respond back with what the IP address is of the resource that I'm trying to access. And it's also going to respond back with the TTL of that IP address, so the recursive resolver knows when to flush it. When the recursive resolver gets that information, it's now going to put it in its cache. So for mikelossman.me, abbreviating here, I have the IP address and I have the TTL now. Now in turn, the recursive resolver can send that DNS request back to me at the host, letting them know that mikelossman.me is at this specific IP address. Let's see what this looks like in a packet capture. So here we have a small packet capture from my WAN interface to the DNS server that I'm using for my house, which is Cloudflare's Quad 1s. In this first one, I'm reaching out to Quad 1s going, hey, I need the IP address for mikelossman.me. Now, what you don't see here is if that wasn't in Quad 1's DNS cache, we don't see that particular service reaching out to everything else to figure out what the IP address is. All we see is the response back that it does have an IP address, could have been from its cache, could have been learned from the authoritative name server. So we have the query where it's like, all right, you wanted the A record for mikelossman.me. The answer is, first off, the TTL is 300 seconds or 5 minutes, which is the default. And the address of that resource is at 205, 196, 221, 194. And there you have it. That's how DNS works in a nutshell. Something that keeps the internet alive isn't as complicated as you might think. Like what you saw? Don't be a stranger. Liked what you saw? Don't be a stranger. Give this video a big thumbs up, smash that subscribe button, and ring the notification bell to join our awesome community and never miss an update. Thanks for watching, and have a great day.